So in the last few videos, we've been talking about Castigliano's method. So this is just a quick recap of how you can apply Castigliano's method. So there's two parts of Castigliano's method. The first part is that you can use it to determine the deflection at any point. So if you know the total strain energy U, and you take the derivative of that strain energy with respect to an applied force at a given point, you can calculate the deflection at that point delta. Okay. In a similar fashion, the second part of Castigliano's theorem says that you can determine the slope at any point, theta I, if you take the derivative of that strain energy term with respect to a moment that's applied at that point. Okay. So, in order to use Castigliano's method, the first thing you need to do is you need to be able to determine the strain energy. Alright, so the strain energy we can define as for different cases of loading. So if you have an axial load, meaning if we have a bar that's pulled or pushed in tension or compression, you can solve for the axial load using this equation. If the area, the elastic modulus, and the force are constants and not functions of x, it simplifies down to just a simple constant. So in a similar fashion, if you have a solid bar under torsion, alright, whereas an applied torque, you can solve it using for this equation here, and then again, if t, j, and e are not constants, and are constants and they're functions of x, it simplifies down to this equation here, where all the terms are constants. So the next case is if you have for bending. So if you have a transverse load, meaning like if you had something like a simply supported beam, alright, where you apply a transverse load, then you have strain energy due to bending and strain energy due to shear. So the strain energy due to the bending moment, you can calculate using these two equations here. So either if we know the moment about the z-axis as a function of x, right, or if we know the deformation as a function of x along the y direction, which is v of c. Alright, so the last part is if you need to calculate the shear. The shear strain energy due to shear, which we have, you can use this following equation here. So the only thing that all these terms, this is just the shear as a function, the shear force is a function of x, elastic modulus, the area, Poisson's ratio. The only thing that's unknown is this k term. The k is a correction factor that you can solve for depending on the type of cross section you have that's undergoing the transverse load. So yeah, so that is it for how you can calculate the strain energy needed to then be able to use Castigliano's method and calculate the shear, to calculate the displacements and to calculate the slope at any point within a structure.